Okay, so we're going to get rolling and get right to this. So today's discussion is going to be on InfoWater Pro, and we're just going to cover water distribution hydraulic modeling using our software solution InfoWater Pro. So just to get an understanding of how Autodesk got into the water space, because that still can be a little bit confusing because Autodesk historically wasn't in the modeling space when it came to water. So Autodesk joined through the acquisition of Innovyze. Autodesk has now been officially in the water space when it comes to planning and water distribution hydraulic modeling. The acquisition of Innovyze happened about 2 years ago, almost 2 years ago. And with that, all the Innovyze portfolio automatically became within the Autodesk portfolio. A little bit about Innovyze, if you're not familiar with Innovyze, it's a global company that pretty much provides water infrastructure software. And when we say water, we're not strictly speaking water distribution. We're talking water distribution, drainage, storm sewer, flood, and asset management. We're a global company, so we pretty much cover the entire globe. We have customers and users all across the globe, and we're in most of the major cities in the U.S. and around the world. Just for us to be able to kind of narrow down our focus from Autodesk water portfolio to our topic of today, which is going to be water distribution. As we mentioned in the previous slide, the water portfolio for Innovyze has historically covered water distribution, storm sewer flood, drainage design, asset management, and operational analytics. For today's webinar, we're going to be focused on water distribution, drinking water distribution. And now you might be curious just how things fit in post-acquisition, post-Innovyze acquisition. So today's conversation is going to strictly focus on InfoWater Pro, which is what you're seeing in this red box here. We would consider this to be a planning tool. So you wouldn't really use this to design or build. You would use this to plan for water distribution systems, whether these are for water main extensions, new zones, merging zones, developer reviews, etc. This is what InfoWater Pro, this is the use case of InfoWater Pro, and this is where we fit in from the planning to operations cycle in the water industry. So again, we're going to primarily focus on the planning aspect of water distribution systems using InfoWater Pro. So just a little bit about water distribution. Water is a broad term. It can mean so many things. We're all very familiar with the water systems that pretty much are what make up our water cycle. So you start with your source water. You have water treatment and then water distribution. Then that becomes wastewater. That wastewater gets treated, and then the cycle goes on and on. And for today's webinar, we're just going to focus on the water distribution aspect, which is primarily the pumps, pipes, tanks, reservoirs, valves, hydrants that are used to deliver clean drinking water to customers from source A or source, whether that source is a surface water source or groundwater source, to the end user, whether that is a residential, commercial, or industrial customer. And the key goals that you're going after in drinking water distribution are primarily maintaining pressure and maintaining water quality. If you can get these two, to the standard that is what your regulators required, then you're pretty much accomplished your goal. Now, some may wonder, why do we need hydraulic models? It's, water distribution is very physical. You go out, you operate valves, you operate hydrants, you turn pumps on and off, you're controlling tanks. What is the use case for a hydraulic model? More specifically, a calibrated hydraulic model. How can I get value out of that? So there's so many different ways that you can get value out of a calibrated hydraulic model, from network capacity analyses to emergency response plans, to evaluating pump stations, performing water loss and non-revenue water studies, to doing developer reviews, optimizing your system performance, and then even doing water quality analyses like water age and chlorine decay, like we're going to explore later in the presentation. And what you're seeing on the right-hand side here is a scale. I'd call it a skeleton. This is just a drinking water distribution representation in a hydraulic model. It has all your pipes, pumps, valves, tanks, reservoirs. They're all in there, and you would use the calibrated hydraulic model to perform any of these analyses that we had just mentioned. So now let's just dive deep into the whole thing about hydraulic modeling within InfoWater Pro. I think now we should have pretty much a high-level understanding of drinking water distribution and the use case of hydraulic modeling in drinking water distribution. Now, when it comes to hydraulic modeling, there might be several different vendors that you might consider. However, today we're just going to focus on specifically what is unique about InfoWater Pro and how you can leverage InfoWater Pro for your application in your utility, or whether you're a consultant or regulator, there's something you can get out of using InfoWater Pro. Generally speaking, the key point that always comes to mind when we discuss InfoWater Pro is just the whole integration with GIS. So the whole thing about the GIS integration is that we're going to realize that till today, models are typically built in a GIS, and then they're migrated or imported into a hydraulic modeling software to then be used to perform hydraulic analyses or perform model calibrations. However, with InfoWater Pro, since you're embedded in the GIS platform, it's a lot more facilitated or streamlined how you can connect your GIS to your hydraulic model. Whether you're bringing in new developments or updating your model based on a GIS update, everything is going to be streamlined using a functionality we have in InfoWater Pro called GIS Gateway. And you're going to notice when you start using InfoWater Pro is that it sits within GIS. So it's the same interface that you would see in the GIS. You'd open that and you'd only see a ribbon that just says InfoWater Pro. And everything hydraulics related is going to be in that ribbon that's titled InfoWater Pro. Aside from that, it's pretty much embedded and within the familiar GIS interface. What are some benefits of being within the GIS platform? The first thing is really the productivity as you're building models or calibrated models or transferring information from your GIS into your model. It's a lot more streamlined, and it's a lot quicker to do regular model builds and regular model updates and regular model calibrations, which pretty much a calibrated model is the core of hydraulic modeling. You can't really dive deep into modeling without having your model be calibrated initially. And the second thing is, with the GIS integration, you also have the ability to share back a lot of model results through read-only or view-only access through a web browser. So you're not necessarily having to take screenshots or submit Excel tables with graphs that you manually create for your various stakeholders to view. You can pretty much be sharing a link with a view-only access to your model results as you do analyses. So when we say leveraging the full GIS data environment, I have a short video here which just shows you some of the benefits of being within the GIS. So you're pretty much going side by side, 3D view in the GIS, and you're also seeing the model pipes that are shown in dark orange and yellow. And you're seeing how streamlined it is as you move and navigate through the 3D view. You're also seeing changes happening in your two-dimensional model view. And everything that you're seeing on the screen, you have the ability to toggle on and off these layers or update color coding based on your preferences and all these things. And this just facilitates the whole modeling, which sometimes, depending on the size of the system, it can be overwhelming just to understand how things are happening in the system, how things are laid out in your city or town or municipality. And so being able to view things side by side in 3D view and 2D view and navigating that through InfoWater Pro can be of value to you. other thing which we touched on earlier was the ability to exchange data between the GIS and InfoWater Pro. So here we have a short video again that's going to demonstrate that. So you're seeing that even things that you're going to be bringing in, any new layers that you're going to want to bring in into your model, whether these are customer meters or hydrants or valve, any layer that you can bring in, it's streamlined because you're within the GIS platform. So you're simply just adding a data layer like you would be adding to GIS, and that can be automatically brought into your model. And for example, what you're seeing here is a customer meter layer that was brought in, and that was just tied. That was just being tied geospatially to your pipes to allocate the domains. And then finally, the last thing with being integrated within the GIS is that you have the ability to publish results online, so folks can view through web maps versus having to create take screenshots and send around Excel spreadsheets. And that's what this short demo video is going to show you here, how you can share results as a web link to your stakeholders. And the convenience of it is they can see it on their screen. You can share this in meetings, and everyone's going to be able to see the same thing and access the same thing. So it just becomes a lot more streamlined, and this is a lot more dynamic than sharing a static screenshot of something. So any new scenario that you run, you can send an updated link with the updated scenario results. So these are just high level some of the key functionalities that, when we talk about differentiators with InfoWater Pro, just being within the GIS platform can allow you to do a lot of these things a lot more easily. And that's one aspect. One pillar of InfoWater Pro is the integration with GIS. The second thing is we're just going to show in the coming slides here some of the streamlined modeling workflows that you can do within InfoWater Pro. And it's just very important, and I'll keep emphasizing that. I'm sorry, I'm in a hotel lobby, and it seems like they're having something, an event going on right now. But the thing that I'll keep emphasizing is that there's constantly going to be a need for calibrating your hydraulic model. And so the first part of this presentation was pertaining to leveraging the GIS to calibrate your hydraulic model. And then this second part is going to focus on how you can use that calibrated hydraulic model to perform modeling scenarios. So first, we're going to start with the most common thing. We're all familiar with fire flow analyses. Many of us have done them in the field. We know the value that we can get out of them, and we know how much work it takes to actually perform even a single fire flow analysis. It can include notifying customers, checking that hydrants and valves are operational, making sure that you're not going to cause maybe flow reversals or any damage to the local surroundings. So with performing a single fire flow analysis in InfoWater Pro, I have a short video that just demonstrates how easy and quickly we can do that. So first, we're setting up the fire flow demand. In this example, we put 1,000 gallons per minute, and then we're just going to go to our run manager, and under fire flow, we're going to set our constraints. Constraints can be either velocity constraints or pressure constraints. And pretty much in a design fire flow in InfoWater Pro, what you're going to be going after is just understanding what the maximum available fire flow is within the constraints that you set. So these constraints can be either, you can say, I don't want my residual pressure to drop below 20 psi. And that's going to give you your maximum available fire flows in the system without having any of these constraints be bypassed. And what you're seeing here is the report manager, which gives you the results of all the fire flow analyses. And then you have the ability to export, sort, or filter these results as you see fit. The next thing that I wanted to cover would be a multi-fire flow run. And in this example, a multi-fire flow, how that differs than a single fire flow run is that a multi-fire flow, you would be asking the model to have demand be coming out of two different hydrants at the same time. So a single fire flow run is simply looking at, I'm running one hydrant up to your required needed fire flow, and then I'm seeing how the pressures, the residual pressures in my distribution system respond. With a multi-fire flow run, you're having multiple hydrants having demand come out of them at the same time. So in the physical world, you'd simply be flowing multiple hydrants at the same time simultaneously, and you'd be evaluating how the system responds to that. And then what you're seeing in the video here is after we've computed the multi-fire flow run, you have the ability to color code your distribution system to get a better sense of what are some of the areas that you might consider bottlenecks. So in this example, the pipe that's highlighted red in this video, the pipe that's highlighted red is actually a 4-inch diameter pipe. It's highlighted red because of the velocity. Based on the color coding, it has extremely high velocities. And so these are ways that you can visually, from performing multi-fire flow runs, you can leverage the map display features in InfoWater Pro to color code your model elements and just get a better sense of system bottlenecks. And then the third example that we're going to look at is a hydrant curve analysis in InfoWater Pro. So the value of a hydrant curve analysis is that you have the ability to automatically generate a hydrant curve, which from my experience in consulting, it gets asked about pretty frequently. And it's as simple as you saw here. You're selecting the hydrant, and then you're just computing you're just running the analysis for the hydrant curve. And what the hydrant curve gives you is a flow and pressure relationship in a specific location in your distribution system. And oftentimes you're going to find developers interested in getting hydrant curves within or closest to the proposed tap that they're going to be making the connection to. And based on the steepness of the curve and the values on both axes, you have the ability to just get a better understanding whether you have any system bottlenecks in trying to meet the developer's demands, or if certain improvements are going to adjust the steepness and the axes intersections of your hydrant curves. And so these first 3 slides that we covered just kind of focused on fire flow analyses and everything pertaining to fire flow analyses within InfoWater Pro. So just showed you the ability to do single fire flow runs, multi-fire flow runs, and develop hydrant curves in a very streamlined fashion. So a lot of these videos were 15 to 30 seconds, and that's pretty much how quickly it is to generate or to run any of these scenarios. The other end of the spectrum after fire flow analyses is pretty much water quality analyses. And water quality analyses tend to be viewed as a lot more complicated and maybe more cumbersome than a typical fire flow analysis. And certainly they can be, however, they don't have to be complicated. I think in InfoWater Pro, one of the differentiators is that you have the ability to very quickly and very easily generate or run water quality analyses. So in this first example, we're going to look at water age. A water age analysis is pretty valuable for 2 reasons. Number one, it can give you areas, very specific areas, where you might want to consider flushing in your distribution systems based on old water, because the correlation between water age and chlorine concentrations can be somewhat beneficial in understanding that some areas are going to have lower chlorine if they have higher water age. So from my experience, I've seen utilities use water age analysis in order to understand whether the flushing that they're doing is actually beneficial, or if it's just not the best use of the operator's time, and maybe not the best use of flushing a hydrant. And so water age analysis, like you're going to see in this short video, is going to allow you to have a more targeted approach to flushing areas that might have higher water age and lower chlorine concentrations, or any disinfectant for that matter. And what you're seeing is after you run the analysis, you're going to have to look at water age graphically and get a sense of how that changes over a given time period, whether that is over a day or more than a day. And then you're going to have the ability to use the map display to color code the water age, and take a look at it at any specific hour that you're interested in. And again, all these color codings are customizable and specific to the user. And then you also have the ability to create an animation that you can share with stakeholders, showing the differences, how the water age changes over a given time period from your scenario. And all these things can be, as you saw, in less than 30 seconds, you have the ability to create and generate these runs. And so any changes or tweaks that you might want to make later, it's just as simple as revising or creating a new scenario with some new, modified, maybe modifications in the alternatives, and then you just run that scenario, and then you can regenerate these results to be shared with stakeholders once again. Another aspect of water quality analyses, which can be, again, a little bit, maybe a step up from water age analysis, can be chlorine decay. And chlorine decay can just show you, based on the source chlorine concentration or dosage concentration at the point of entry, you can use a calibrated model like InfoWater Pro in order to analyze how the chlorine concentration is varying throughout your distribution system based on your hydraulics and your demand. And so in this short video, we're going to take a look at how to set up a chlorine decay analysis and some of the features that you're going to be put in. So here we're setting a chlorine decay analysis. There's some properties that are defaults, but you have the ability to change them as needed. And pretty much the primary input is that you're going to want to let the model know what your influent, what the point of entry dosage is, and then you're just going to run it. And when you run it, you can go to any model junction and graph the chlorine decay concentration, and you can see how the chlorine concentration changes over a given day. So this can allow you to make sure you optimize a chlorine dosage, so you're not overdosing and you're not underdosing. And these, again, provide it provides a lot more data points than having the operator crew having a sample at any given hydrant just for you to understand what the chlorine concentrations are. So as long as you have a calibrated hydraulic model, you can have the ability to have more data points when it comes to understanding how chlorine concentrations vary throughout your distribution network, whether that is under an average day demand, a minimum day demand, a max day demand, or even a forecasted demand that has yet to happen. And these are the flexibility, this is the flexibility that you get with doing hydraulic modeling. You don't have to do things in the field first. It's actually the model comes first. As long as it's calibrated, you can use it to do all these analyses before you let your operations crew that here's what we're going to do, before you invest financially into having your operations crew do it out in the field. The third pillar in water quality analyses that we're going to want to cover here is a source trace analysis. And a source trace, from my experience, has many different uses. One of the most common use cases that I got exposed to is in a utility that might be fed from different sources, whether that is multiple groundwater wells or even multiple interconnections that are from different neighboring utilities. And or even two different zones that have PRVs or PSVs that are just regulating flow from one zone to the other. If these two different zones or if these two different neighboring utilities have different water quality, it's very important for you to know where the boundary is between areas in your system that are being fed from that one source and areas that are being fed from that second source. And so performing a source trace analysis becomes very valuable as you try to figure out what that boundary is going to be in your distribution system. And as we're going to see here, doing that source trace analysis is very straightforward in InfoWater Pro. It's as simple as going into the run manager and just changing the water quality run to trace. And then you're running that, and then you're able to view the results in your distribution system. It's going to give you at any given time step what the percentage of flow is coming from each source. So for example, if you have let's say a customer is between 3 different groundwater wells, you're going to be able to use the model to say, okay, at this time, the customer is getting fed 70% of the water is coming from ground well number 1, maybe 20% is coming from well number 2, and then 10% is coming from well number 3. Again, this is a simplified example, but any water system that has different sources of water or interconnections, whether they're emergency or wholesale, you're going to benefit from performing a source trace analysis for you to understand, again, the mixing, where the boundary is between source A and source B. And then finally, so this is something that is very unique to InfoWater Pro that I wanted to leave at the end for 2 reasons. It's not very common that you find folks using a modeling platform for pressure zone analysis and what we call pressure zone manager. So that's why I wanted to cover fire flow analysis and water quality analysis first, because these tend to be more common more commonly performed using hydraulic models. That being said, there's something very unique in InfoWater Pro called Pressure Zone Manager, which allows you to automatically generate pressure zones based on your established boundary conditions, whether these are PRVs, PSVs, closed valves, and when the model automatically generates or recommends these pressure zones, you're going to have the ability to then create a system schematic. And you're going to see in this short video here how that is done. So we've created the pressure zones automatically using, again, we told the model what the boundaries are and what valves are open and closed, and then we have this ability to automatically generate these pressure zone results with all the data that are pertaining to each pressure zone. And these can be imported, or these can be exported in PDF format to be shared with stakeholders. But this system schematic is really a very unique feature that, from my consulting experience, we had a dedicated AutoCAD group that would simply be creating system schematics in water distribution systems that us as the modelers we would then use to better understand mass balance and to better understand how things are connected in a specific water distribution system. However, in InfoWater Pro, once you've run Pressure Zone Manager, you have the ability to automatically generate the system schematic, which, as you saw, it's clickable. You can click on any element in the system schematic, and it's going to automatically zoom into that element and show you where that is in the distribution system. In addition to that, you're going to have on the right-hand side, lower right-hand side here, you're seeing under details, you're going to have a better understanding of some of the key details of each pressure zone. These might include the minimum and maximum pressures. They might include the demand, the number of customers, maybe the water quality if you've run a water quality analysis, in addition to just understanding how your pressure zones are connected, which is very important to us as modelers when performing mass balance. And so this is, to me, when I got exposed to this, I was like, this is mind-blowing, and I wish I knew about this earlier. And so that's why I thought I'd leave it towards the end. So if the first part was a bit overwhelming, hopefully the Pressure Zone Manager part sticks and it's something that all of you find beneficial. But that being said, that's pretty much all I had for the day. I do apologize.